Hi, welcome to clickmyproject.com. Now going to see different trees for mining data streams based on the McDiarmid's bound. Our basic domain is data mining. Generally, data mining is the process of analyzing data from different perspectives and summarizing it to useful information that can be used to increase revenue, cut cost, or both. Our main concept is the decision tree. Decision tree is a decision support tool that uses a tree-like graph or model of decisions and their possible consequences, including chance event outcomes, resource costs, and utility. It is one way to display an algorithm. Traditional techniques for data mining require multiple scans of data to extract the information, which is not feasible for stream data. It is not possible to store an entire data stream or to scan through it multiple times due to its tremendous volume. The large amount of events in data streams which had previously happened is usually extremely large. Moreover, the characteristics of the data stream can vary over time and the evolving patterns needs to be captured. To address this problem, as we indicated several methods including forwarding tree algorithm. Then next, let's start abstract in our main project. The forwarding inequality is not appropriate to solve the underlying problem. The forwarding inequality is not an adequate tool to solve the underlying problem. Consequently, all methods and algorithms developed in the literature for mining data streams, if they use the forwarding bound, should be revised. The McDiarmid's inequality used to properly is an effective tool for solving the problem. The well-known result forwarding bound for arbitrary heuristic measure cannot be obtained either from the forwarding inequality or from the McDiarmid's inequality. To prove two theorems presenting the McDiarmid's bound for both the information gain used in ID3 algorithm and for Gini index used in classification and regression trees algorithm. Now watching data flow diagram for McDiarmid's tree algorithm. First you have to start the process, then load in the data set. After you have to load the data set, remove the data. Remove the data means noise removal and data unwanted data has been deleted. Then we have to find out the McDiarmid's inequality values. Then we are going to find McDiarmid's bounded values. If bounded values is greater than inequality means information gain, going to the information gain, find out the information gain. Else find out the Gini index. These two values are combined to both matrix for McDiarmid tree construction. Then show that tree. Stop the process. Now let us start a project demo for decision tree for mining data streams based on McDiarmid's bound. First you have to choose another data set. I have choose demographics.txt. This is our data set. I have to load dataset in our database. Upload data takes several few minutes. Dataset loaded successfully. Then view data. This database stored dataset. Then we have to go into pre-process for remove data. Dataset pre-process, then view that data. Then we go into transformation. First you have to choose partition each label, class labels. Then classify based upon our labels. Household, person ID based on, then age based, class based, worker based. Then we are going to find out information gain. First we have to choose information gain. Total number of observation data set 414. Total number of class 2. Distinct classes 1 and 2. Count of class 1 is 298. Count of class 2 is 206. Probability of class 1 is 0.502. Pi log 2 of pi class is minus 0.498. Probability of class 2 is 0.497. Same as probability of log 2 of pi class 2 is minus 0. Total info of t is equal to 0.98983. then bound for information gain. The information is based upon every class labels. First we have to choose household ID. Info household ID of ID is 0. Information gain of household ID is 0.09983. Same as all class labels. Then going to find out Gini index. First you have to get Gini index, Gini values. Sum of classes 0.502. Gini index of it is 0.4999. Find Gini index. Sum of Gini is 7.96. Gini index of G minus 7.496. Then how to find bound for Gini index. This is bounded for Gini index bounded for in each columns labels. Each column labels. Then we have to find out Gini ratio. First you have to split information. Then view our ratio in each labels. First you have to household. Info of gain 0.999. Split info 3599 1.1036. Then gain ratio. Then we are going to search Gini ratio. First you have to decision maker. This is decision maker of every class labels. Household ID, person ID, age, class, worker, household income, household size and household home location ID. Then split and pruning action. This is splitting and pruning for in each columns. Then we have to tree for decision tree. We have to choose each column labels. First we have to choose person ID view tree. This is based upon person ID tree. Then we have to choose worker based. Then we have to choose household ID. Not because of 0.0 is our initial values. Then we have to choose household income to household size. This value is also 0.0. This is demographics portland. Thank you for watching this video.